Okay, today we will learn how we can determine the concentration of target element that present in a sample using standard addition method. Okay, these are the examples that we will go through. Okay, in these examples, I will simplify this question into a diagram. Okay, first of all, this beaker consists the sample solution that present with iron. Okay, based on the example here, okay, in these examples, the iron were measured using atomic absorption spectrometer. Before we measure the concentration of the iron that present in the sample, we have to go through some sample preparation. Basically, we need to prepare a series of standard solution. In order to prepare it, first of all, we have to transfer a certain volume, or in this case an equal amount of the sample solution into 5 different volumetric flasks, which in this case which is 10 ml. Okay, next, after we add the sample, a certain volume of standard ferric solution where the stock concentration is about 11.1 milligram per liter, and we will transfer a certain volume only into 4 volumetric flasks, okay, where the first one will remain as it is. Okay, for these 4 flasks, we intend to prepare we want to edit the amount of iron with this concentration that's shown here. Okay, how we can work out how much volume of this stock to be added in order to prepare the desired concentration? Okay, we will use this formula. Okay, the M1 actually the concentration of the stock, which is 11.1. The V1 is the volume that we intend to find out. M2 represent the concentration that we want to prepare, which in this case is 1.11. And the V2 represent the total volume in this flask, which in this example is 50 ml. So if we go through the calculation, okay, if you go through in the Excel, you can in order to find out how much the volume, you work out the which is in A7 actually represent the M2 multiplied with the total volume 50 divided by the M1, which in this case is 11.1. So actually for this for the flask 2, the volume that we need to add is 5 ml. Okay, after that, all these flasks will be diluted to the final volume with potassium thiocyanate. Okay, and the absorbent that we measured, in here. Okay, these are the absorbent that measured. Okay, so from the concentration of the iron and the absorbent, we can plot the calibration curve, as shown in here. So the next step we need to do is we have to find out what the value of x-axis when the y is 0, basically when the absorbent is 0. Actually at this point, the value actually represent the concentration of the ion that present in the 50 ml volumetric flask. Okay, so after you work out to find out the concentration, which in this case is 1.4. Okay, just ignore the negative value. So 1.4 actually represent the concentration that present 50 ml volumetric flask. But please remind that we want to find how much the concentrations of the ion that present in the real samples. So you, in this case, in this preparation, from 10 ml will be diluted up to 50 ml. So the concentration 1.4 we have to multiply with the dilution factor. In this case, 50 divided by 10 is the dilution factor. So after we multiply, we get 7. So 7 mg per liter actually represent how much the concentrations of the ion that present in this sample solution. So we achieve our objective, which want to determine the concentration using the standard addition method.